Hello, in this video we're going to look at consumer welfare and talk about compensating variation and equivalent variation. So our problem is to find the compensating variation and equivalent variation from a hypothetical move from city A to city B. A person living in city A has a utility function that's given by the following. This is a perfect complements utility function. The person's income is $5,000. The price of good X, $1, price of good Y, $2, forming the budget constraint, where income equals the price of good X times units of good X plus the price of good Y times units of good Y, and making our substitutions. We get the budget constraint in city A. If the person were to move to city B, utility function is unchanged. Income, we're going to assume, is unchanged. The price of good X is unchanged, but the price of good Y increases now to $3. And forming the budget constraint from these prices, we get something that looks like this. Okay, moving on. Let's start by solving the compensating variation. We can define the compensating variation as the amount of money to give to the consumer to completely offset the price increase. So the consumer's utility is unchanged. That is, the consumer stays on the same indifference curve. So let's start over here on the left in city A. We have the consumer's perfect complements utility function. We're going to maximize utility, and the way you do that with this functional form is you set what's in parentheses equal to each other, so X equals 2Y, and then you're going to plug that into the budget constraint. Here's the budget constraint from the last screen. And where I see an X, I will now plug 2Y. So 5,000 equals 4Y. Dividing through by 4, the consumer will purchase 1,250 units of Y. Plugging this 1,250 units of Y into this equation up here, X equals 2 times 1,250. The consumer will buy 2,500 units of good X. We're going to evaluate our utility function at those values. So for X, we're going to plug in 2,500. For Y, we're going to plug in 1,250. And we see that utility is the minimum of 2,500 or 2 times 1,250, which is also 2,500. So the consumer's utility in city A is 2,500 units. Moving on to city B, where we have a slightly different price structure. We're going to first set the utility function in city B equal to 2,500. And then we're going to maximize utility. So we take what's in parentheses and we set it equal to 2,500. So 2Y equals 2,500, or Y equals 1,250. And X equals 2,500. So just X equals 2,500 directly. We're going to plug those values in the budget constraint. Now here the budget constraint is different. We have a different set of prices in city B. The price of good X is $1. That's unchanged. But the price of good Y, instead of being $2, is now $3. So for X, we plug in 2,500. For Y, we plug in 1,250. And we see that the person would need $6,250 in city B to compensate for those higher prices to maintain their same level of utility as found in city A. So the compensating variation, by definition, would be this calculation, $1,250. The consumer would need an extra $1,250 in city B to compensate for the higher price of good Y. Another way to think about this is that the combination of income of $6,250, a price of good X of $1, price of good Y of $3, gives just as much utility as a combination of income of $5,000, but at the lower prices. Price of good X, $1, price of good Y, only $2. All right, the last thing we're going to do is the equivalent variation. This is going to be the amount of money to take from the consumer that would lower her utility by the same amount as the price increase. So the job in city B we're going to maximize utility in city B. So once again, setting x equal to 2y, plugging in to the budget constraint. Okay, the consumer's income in city B, we said would be $5,000. So price of good X is $1, price of good Y is $3. So where I see an X, I'll plug in 2Y. So 5Y equals 5,000, or Y equals 1,000. Plugging that 1,000 up here, X equals 2,000. Evaluating the utility function at Y equals 1,000 and X equals 2,000, the person's utility would only be 2,000 units. Going back to the job in City A with the lower prices, if we set utility equal to 2,000 and we're going to maximize utility, we take what's in parentheses, set it equal to this lower level of utility. So X equals 2,000, Y equals 1,000. Plugging those values into the budget constraint at, again, the original or lower prices, we find that the person's income would be $4,000. Okay, so an income of $4,000 with the lower prices would provide just as much utility as an income of $5,000 at the higher prices. The equivalent variation, therefore, is going to be the differences in income here, or $1,000. So, and again, another way of thinking about this, the combination of income of $5,000 with the higher prices gives just as much utility as a combination of lower income at the lower prices. Okay, I hope you found this video helpful.